Okay, we will start the session. Welcome and thanks everyone for joining. My name is Yuri Vandenbrekel from Spirent Communications. As an introduction, Spirent Communications is the global market leader in Ethernet lab testing tools. So we have a lot of experience when it comes to scaling and performance testing network infrastructures, from enterprises to service providers to cloud networks. And today we would like to share with you our perspectives on what an architecture looks like to serve a billion connections in and out of the cloud, and what that all encompasses in terms of delivering scale, performance, availability, and security. So in this presentation, we will walk through an example cloud. Then we will talk about how to scale the network infrastructure to support this large cloud. And then finally, we will go over how to test the cloud infrastructure and applications themselves to deliver the expected quality of service and quality of experience to the users of the cloud. So before we go into the details, I'd like to spend a few moments on what cloud computing is. I've heard and seen this presentation or this diagram in other presentations, which is good because it's a general accepted definition of cloud computing provided by the National Institute of Science and Technology. And in that, they describe cloud computing to have multiple aspects. So one of them is essential characteristics of a cloud. So a cloud is a large pool of resources that can be used by many different people. The characteristics of that pool of resources is that it needs to have broad network access, so a lot of people and services can reach it. It needs to have rapid elasticity, meaning you start off with one user, one application, and as that grows, you can very easily add different appliances and services to it. It also needs to be a measured service, so you can bill users appropriately. And finally, it needs to be available on demand, so it shouldn't involve any user interaction on the cloud service provider side to offer the services. There's different types of cloud services. One is infrastructure as a service. That's the most basic element, if you will, in cloud computing. And on that, you can run an OS in the cloud, such as a Linux or a Windows server, and you have, as a user, full control of everything that runs on top of that. So it's almost exactly like managing your own server in your own data center, but then without having to deal with the physical hardware. Then on top of that, but not necessarily on top of that, you can run platform as a service. And platform as a service are things like web hosting, database services. So the user of a platform as a service uploads his website without having to worry about the underlying physical and OS infrastructure. Then finally, the top layer of the cloud computing services models is software as a service, where the user comes and just makes use of the service, such as webmail and other things alike. For all of these service models, there's different deployment models. And one is private. So as an enterprise, you could run a private cloud on which the different departments you can offer these different services. You can do it in a public form as a service provider, where the cloud is shared by thousands of different users. Then you have the hybrid form, where a company or enterprise has a private cloud, and when they need extra capacity, they can make use of the public cloud. And then finally, there's community clouds. So an example community cloud is for government. If you build a cloud data center for a particular set of requirements from the government, you can offer services to the different government departments. So let me make a small correction here. NIST is the National Institute for Standards in Technology. If you take this model and then translated it to a network